Over the past few years, we've seen a number of different trends in the mechanical engineering market. One of them is the increasing number of industrial robots that are used in machines. Robots are increasingly replacing stationary kinematics to perform tasks such as pick and place operations and palletization. But this new trend also poses some challenges for mechanical engineers, and we would like to take a closer look at these challenges now. The familiar world of automation, consisting of SIMATIC products and the TIA portal as an engineering framework, is now being enhanced by a robot cell. This robot cell consists of a separate controller, a separate operating device, and the robot. And this is where the challenges for mechanical engineers begin to surface. A separate operating device means a different operating philosophy from that of the overall machine. And a separate controller also means a proprietary engineering tool, which varies from one robot manufacturer to another. At Siemens, we have a solution for this. Robot manufacturers such as KUKA, Denso, and Stäubli provide function block libraries that allow the robot to be programmed in the TIA portal. These libraries contain function blocks for various traversing movements, such as linear traversing or stop robot. This creates an opportunity to perform complete engineering of the system and robots solely within the TIA portal. We also offer you the chance to perform robot operations via a Siemens HMI. For this purpose, we provide you with a standardized user interface for different robot manufacturers. We would like to show you this now in a live demonstration. Exactly, Tobias. Let's do that by taking a look at the application example in the TIA portal. In this practical example, you will find the Denso library for the TIA portal and various functions that we have prepared for you. You can also see an example of a robot program where different commands have been called up. We've also prepared a new user interface for you to enable robot programming and operation. You can see the start screen of this user interface here. And this is where you can switch the robot off and on, and you can also see various types of information about the robot, such as its position. You can also define operating ranges for the robot and assign names, enter tool offsets, or even the payload. To move the robot, click on Move. You have different options for moving the robot. For example, you can jog the robot in the work coordinate system, but also in the joint coordinate system, or tool. You can also have the robot perform a linear traverse. In the joint coordinate system, you can move the tool center point or set point-to-point interpolation. First, we'll use the joint function to move the robot to the starting point. To do so, first we'll read the robot's current position and input the following set point values: J1, minus 90 degrees, J2, 0 degrees, J3, 90 degrees, and J5, 90 degrees. The robot moves until you let go of the Move button. Now we are standing at the starting point of our path. We teach this position as the home position. Next, we move the robot to the second point. We do this in the base coordinate system. To do this, we once again read the robot's Cartesian position and enter the set point value 200 millimeters for the x-axis. We move the robot to this point and save this position as pre-pick position 1. Then we move the robot to 400 millimeters on the z-axis and teach this point as pick position 1. Now we move to the left, from the robot's perspective, entering a set point value of 200 millimeters for the robot's x-axis. And we teach this point as pick position 2. And now we move the robot up along the z-axis to 495. And we save this point as pre-pick position 2. We have created a point cloud, which we can see here in our position list. We can move our robot towards any random position. For example, pre-pick position 1 or pick position 2. Now we can write an online program in which we switch to the view Teach Path. So we're going to use Path 1, applying all the positions from the point cloud that we have taught. The first point is Home, and the second point would be pre-pick position 1. The third point would be pick position 1, and the fourth point back to pre-pick position 1. For the fifth point, we move the robot to the left side, from the robot's perspective, to pre-pick position 2, and then to pick position 2, and back to pre-pick position 2. The last point is Home again. You see an X mark here showing each point. That means that for each point, we still have to adjust a parameter, namely the motion type. With this parameter, we define the type of interpolation of the movement. In other words, P2P, point-to-point, or linear. For each point, we save this parameter as linear. And when the points have been completely defined, green check marks appear in place of the red X marks. Now we have green check marks everywhere. So the program is properly defined and ends at this red line. Now we would like to test the program which we have written online, namely Path 1. To do so, we activate the step mode and set override to 100% and launch the path movement. The robot is located at the initial point, Home. Second point, pre-pick position 1, pick position 1, and back to pre-pick position 1. Now left to pre-pick position 2. Z downward to pick position 2 and back to pre-pick position 2. And back to Home. Now the program has been tested, and we can start it automatically. Thus, we can see the entire routine that we have programmed online. Of course, we can also adjust some parameters for this path, such as blending or moving faster for more acceleration. We start the same path again and see that the robot is blending and moving faster. By doing this, we have completed the robot program. Yeah, and that's all there is to it. Thank you, Ganesh. Let's summarize the benefits one more time. One engineering environment for you and robots. a uniform operating philosophy, manufacturer-agnostic robot programming, and last but not least, identical faceplates for the different robot manufacturers. As you can see, robot programming can be that easy with the TIA portal.
Siemens. Ingenuity for life.